So the battery constructed with using two tubes as per the figure with a dimension of A, B, and C is given. So which dimensions are required to find the reaction at the end of each tube? So a load of P is given. To find the reaction, there will be two forces acting on this bar. One force is acting a reaction force of acting upwards, which creates a momentum. Correct? So for finding the momentum, we need the axial length of this, and what about C? Is the value of C required for finding the momentum of this tube to the direction? Because this is the height of this. Is that required? Only these two parameters required, correct? So only A and B is required to find that. Okay, the option is A. Is that clear? So we'll move on to question number 4. Read the question and understand the concept very clearly. Yes. The atmospheric pressure is 14.3. Atmospheric is 14.3. Okay. So it's a manometer, a pressure U-tube manometer having an unknown fluid containing a gas. The tank pressure is 19.4 and atmospheric pressure is 14.7. If the fluid height in the manometer 35 inch, the density in lbm per feet cube. So they are asking for the density in lbm per feet cube of the fluid. It's unknown. It's not known to us. So there is a fluid. Let's consider air is also a fluid. Okay, will be in this container with 19.4 psi pressure, and this pressure we don't know, but a high feet, inch, but head is given. So be clear with the concept. If the pressure at this is 19.4, can I say this pressure is also 19.4? Correct? It's a Bernoulli's equation. So both the fluid will be on same level, will have the same pressure. So I can consider this as also 19.4. We know P1 is equal to 14.7. Already written. Okay. P2 is equal to P1 plus rho G H. So P1 I know, and P2 is 19.4. P2 minus P1 is equal to rho G H. P2 19. P2 is equal to 19.4 psi. So 19.4 minus 14.7 is equal to rho into 32.2 into H 35. So substituting this, rho is equal to 19.4 minus 14.7 by 32.2 into 35.
So the inch we don't have to give.
They are asking the in feet cube. Okay. So we'll change PSI pound per square inch. Let's consider this also to be changed. So for converting this, you have to multiply with 144. I will multiply here with 144. And 32.2, it is equal to 32.2 feet per second square. So feet and 35 is inch. It is plus. So you will get density is equal to 7.206 lbf plus PQ. So be careful in lbf and lbm. It's a pound force and it's a pound mass. You will get the answer in pound force. So converting this into pound mass, 7.206, you have to multiply with density. So it will be 232 pound mass per PQ. Yeah? Any doubt in this? Do you want me to explain once again?
Yes, 144.
Yeah, it is square inch to square feet. Converting this into for conversion of square inch, 12 into 12. That is 144. Is the concept clear, or do you want me to explain once again? Shall we move on? Yes, sir. Shall we move on? Okay. So the answer is 232. We go to question number 5. So a proposed piping and pumping system has 20 psi static pressure and pressure discharged to atmospheric 160 feet above the pump. If the piping pressure loss 20 feet head, the minimum pressure rating psi by the system is mostly early. So here pumping system with static pressure is given. The static is equal to 20 psi discharge atmospheric pressure 160 feet. If the friction has head loss is equal to, and piping friction as a head, that is equal to 20 feet. So totally 3 types of losses that is happening here. One is static, one is due to atmospheric pressure, and one is due to friction loss. So minimum pressure rating required is equal to P static plus P atmospheric plus friction losses, head loss. So either convert this heat to psi, or they are asking in psi, right? So you have to convert all this heat to psi. Two point 3.31. If you are converting psi to feet, please multiply by 2.31. If it is feet to psi, you have to. Okay, so 1 by 2.31 is nothing but 0.433 plus 20 into 0.433. So adding all together, you will get total pressure required is 98. Yes, sir. Just you have to convert the units. The rest is same. Okay.
Point 433 is your what?
I'm converting the unit from feet to psi.
That's there in the calculator.
You can use the conversion table.
Yes, there.
Yes.
So here the fluid is air or water.
Pardon?
Here in this question,
They are asking for the speculating.
yeah, is it pumping air or water in this one?
No, this is water.
What,
But it's not even required for solving this because we are just taking the conversions unit and we are not considering the whether the medium is water or acid or anything else. So before solving this, please note this two formula, a very important one to find the cooling load. If any heat transfer or any two temperature difference in given and they are asking for the heating load or cooling load, you have to use these two formulas. Q is equal to Q in BTU per hour is equal to 5 GPM into 500 delta T. If the flow is given in GPM, if the flow is given in CFM, it's 1.1 delta T. Very, very important formulas for solving these types of problems to find the cooling load. Okay. Please remember this. This is very important. So let's go to the question. A water run around a circle, assume coil bypass factor is named. No heat is given. And conditions are such, no condensation occurs in the coil and water loop operates between two temperature difference are given. CFM and T4 is equal to 75 degree Fahrenheit. T3 61.2 degree Fahrenheit. And we can PGA. So, yeah. Here they are asking for the leaving temperature T2. So either we can use PFM as both the section 1, 2, 3. Either we can continue with the CFM or we can change to GPM and again go back to CFM because in this parameter CFM is given and T2 is given. For the ease of calculation, I am using CFM because 1 and 3 is CFM. So from this, I will calculate for the CFM and we will get T2. Okay. So first let's find out what is Q. Q is equal to CFM into 1.1 delta T. Further, let's take for section 3. You can try with section 2 with GPA as well. The answer will be the same. Okay. I'm taking the section 3. CFM given is 5000 CFM into 1.1 delta T 75 degree Fahrenheit minus 61.2 degree Fahrenheit. So calculating this, you will get Q is equal to 75900 BTU per hour. So I got Q. Now I can substitute the value of Q here. Similarly, for section 1, Q is equal to, here it is 4000 into 1.1. Let's consider delta T as it is. So instead of Q, I can substitute 75900 by 4001 into 1.1 is equal to delta T. Delta T is equal to 17.25. Here delta T1 is given. So T2 minus T1 is equal to 17.25 implies T2 is equal to 17.25 plus 35. So you will get 50.5 degree Fahrenheit. Understand? Clear, sir?
Sir, in this equation, the delta T have to be in Fahrenheit, right? Not Celsius.
No, it's in Fahrenheit. No, if,
Cannot use it delta T Celsius after convert it, right?
no, actually, it is just a subtraction. You are not multiplying this parameter with anything else. So even if it is a degree Celsius or Fahrenheit, it doesn't matter for that.
We don't need to convert it into research.
No, no. So shall we move next question? Clear on this?
How was it about equals?
Pardon?
Q2, 1, 2 and Q3, 4. So we make them equal.
No, I'm just applying the formulas. This section are separate and this section are separate.
Then the thing both are
But the Q is equal.
Q.
Q is equal. Even if you try with the GPM, you will get the same answer. I tried it. Okay, just you this formulation. So question number 6. Answer is 52. Fair. So a cantilever beam of UDL is applied at 10 lbm per inch over a section of 12 inch. As shown in the figure, the shear force in the beam at a distance of 18 inch from the wall. So from the wall, they are asking for the 18 inch. What is the shear force? So let's draw the shear force diagram first. For the uniformly distributed load, it is going to 120 pounds per inch square. Correct? 12 points of 10 pounds per inch of load is acting in 12-inch distance. It will be 120. After that, there is no load and it is acting straight. Correct? So they are asking for the distance of 18 inch from the wall. So it will be around 12 inch and half of this 6 inch. So half of this will be 120 by 60 pounds per. Yeah. Hello. So it is option A. Try this. So we have solved this problem in our first class. If you remember know the concept, we'll go to next question. If you have any doubt, I will recall this question once again. The same question, the same parameter. Do you want me to solve this? The question. Do you want me to solve this again?
Yes, please.
Yeah. So specific heat above freezing 0.79 CP above and CP below is 0.37. Lateral heat of fusion is 106 pt per pound. And freezing point 27 degree Fahrenheit and thermal conductivity 0.8 BTU per